The last relationship that we will investigate in this chapter, so far we have seen that pressure is a constant, well, let's say it's a constant times the inverse of the volume, that Boyle's law, that volume is a constant times the temperature, that was Charles' law. So the last one that we will see is Avogadro's law. What is Avogadro's law? In this case, the experiment is run at constant pressure and constant temperature. And and I'm not sure it was Amadeo Avogadro's in this case running the experiment, so I cannot attribute it to it. But what the experiment tells you is that if you put a certain quantity of gas, that will become a certain volume. If you double the quantity of gas, you will be doubling the quantity of volume. In other words, the gas is proportional to the volume. The quantity of gas, the number of moles. Notice that I say number of moles, not number of grams. What counts here is the number of particles, the number of moles, which is not necessarily the number of grams. There is a molecular weight involved in there. So what this is saying is that if you double the number of moles, the number of the number of liters, the volume will double as well. That's what Avogadro's law is. So let's run a problem, a very simple problem, just to plug in some numbers into an equation. It says that you have a mole sample of a 0.225 mole sample of helium, which has a volume of 4.65. So let's say that you have that container in which you have put 0.225 moles of helium, and the volume that you see here is 465 liters. And if you put an unknown quantity, let's say this is volume 1, so for situation 1, volume 1, and number of moles 1. So the question is, how many moles do you need to put in the container so that the volume of how many moles of helium so that the volume is 6.48 liters. Okay, so this will work in a very similar fashion to the Charles law problem. Notice that if N1, the number of moles, is proportional to the volume, and you can say that in the second experiment the number of moles, of course, is still proportional to the volume. Being that that constant of proportion the same, you can do something like that, in which CV1, this is just solving system of equations. Hopefully all of you are familiar with this. The constant of proportionality is multiplying and dividing, so it goes away, and we want to know N2. So how can we figure out N2? So this will go to the other side of the equal. So N2 is N1. Alright, so NV2 will be multiplying, and V1 will be dividing. Okay, I think I have the calculation right here. Notice that N2 is equal to N1 times V2 divided by V1. You just need to plug in the numbers, and then you calculate the number of moles that you should add. Let's see, does this make sense? Does it make sense that the number of moles that I should add, actually I have to add them, I don't have to subtract them, because I had initially 0.225 and now I have 0.314. Well, it makes sense because the volume has increased. And what Avogadro's law is saying is that if you increase the volume, it has to be because you are adding more matter, you are adding more moles. Okay, so this is the relationship between volume and mass. And the next video we'll be able to combine these three experiments into one single equation. We will figure out what this constant of proportionality is, and we'll be able to attack any kind of problem.